Okay, good morning. I am here to brainwash you into something crazy. But let me start out by saying a strange thing happened to me in May, which is that I got a job. After many years as a consultant, I work for a real company and they pay me on holidays and the whole salary thing. It's pretty interesting. And the reason that I decided to get a job was because as a consultant, I used to go into companies and I would pair with people and teach them TDD and refactoring and all that sort of thing. But I never got to do anything but be a visitor to a code base. I had my own open source stuff. I've had a closure testing tool that's been fairly popular, that's been going on for 3 years. But it's small and they don't pay me to work on it. So I wanted to have a chance to work on a large code base over a long period of time and see it get better and better over time, because that's something that's really motivated me for a long time. So the fact that I'm now getting paid to work producing software caused me to sort of reinvigorated my interest in a question that's been interesting to me for a long time, which is what is it that makes a good programmer? How do you become a good programmer? And in particular, how can I become a better programmer? And so this talk is about some of the things I've been doing recently toward the end of becoming a better programmer, and I'm presenting it to you in the hopes that some of it might help you in that same goal. So, I have a self-improvement goal, and this particular part of my goal is in some sense based on this book, Thinking Fast and Slow by Daniel Kahneman. And what he does is he's a psychologist. He won the Nobel Prize in economics. He's one of the founders of economics that recognizes that human beings are not, in fact, rational calculating machines, but they have brains that often behave in irrational ways. And he, in this book and in his work, divides the brain into two systems, he calls them, and he gives them the catchy names System 1 and System 2. I can never remember which one is which, so I call them the effortful system and the automatic system. So as an example of an effortful activity, something that's done by the effortful system in your brain, there's adding two numbers like 123 plus 82. Now, when you solve that problem, if I ask you what 123 plus 82 is, most of you can't come up with the answer immediately. Some of you would do the thing you learned in grade school where you add to the left to the right or right to the left and you carry the 1. Some of you probably know some calculational tricks like 12 plus 8 is 20, and then you have 5, so it's 205. So that's a faster way of coming up with the answer, but it's still a step-by-step linear effortful activity. Now, in contrast to that, if I ask you what 2 plus 2 is, you don't have to go through any procedure to get the answer. You immediately know the answer. And in fact, you can't not know the answer to 2 plus 2. It's impossible for you to hear 2 plus 2, what's 2 plus 2, without thinking 4. In the same way, when I say a word in your native language, you can't hear that as a sound. You hear it as the meaning of the word, not as the actual sound, because the automatic system is translating the sound into meaning before you, the effortful system, has a chance to get a hold of it. So another example of an automatic system is if you've probably had the experience of you're driving on a highway, not in busy traffic, but out in the country somewhere on the interstate, and you realize you've been absolutely paying no attention to driving for the last half hour. You've been going around curves and you stayed between the lines and everything, but you consciously have no memory of doing any of that stuff. And that's because the automatic system takes charge of that sort of thing for you. In contrast, if you're like most people and you're trying to get your car parked in a really narrow spot, what you will find is you have to be extremely conscious of your car. You have to think about the dimensions of your car, where it is in relation to the things around it. You have to think about things in a way that you don't think about the lines on a highway when you're driving. So, final example, if I take you to the top of a hill in Scotland and I say, could you count that flock of sheep below? That is an effortful activity for you. You will have to keep track of which sheep you've already counted and deal with the fact that they're moving around and so on and so forth. But if I take you to the top of a hill in Scotland and show you a group of sheep and one of them is green, before I even say anything to you, you will notice that that sheep is green. You can't, unless you're colorblind, you will not be able to not notice that the sheep is green because your automatic system is in charge of that. So the effortful system is so-called because it actually is effortful. It's work to do that. It's work to add numbers up all day. At the end of the day, if your job is adding 5-digit numbers, you'll be tired. At the end of the day, if you're programming, you'll be tired. You can as long as you're actually working and not on Twitter or something like that. The way you can tell if a task is effortful or automatic is your pupils dilate when you're performing effortful tasks. So if you're a subject in an experiment and you've been given a task to do, your pupils will dilate roughly in proportion to the difficulty of the task. And a researcher can, by looking at how your pupils are dilating, make a reasonably good guess at whether you'll give up on the task as being too hard or not. So that's the effortful system. It's tiring. The automatic system is not tiring. You do it all the time. It's completely automatic. It's always on. You have no real control over it at all. It also operates in parallel. So if I'm taking you up to the top of that hillside in Scotland and you're looking at the green sheep, your automatic system is also continuously monitoring to see if something's sneaking up on you. And it does that even though there are two parallel tasks. In contrast, the effortful system really can only do one thing at a time. So if you give somebody the job of adding 5-digit numbers while simultaneously parking their car in a really tight space, they will do markedly bad at both of those tasks. They will have to switch between the two. Okay, so I'm kind of building up the automatic system here. It's sounding pretty good. And unsurprisingly, the effortful system, since it's tiring, also tries to be lazy. And it offloads work whenever it can onto the automatic system. And that's good because that reduces the total amount of effort you have to put in things. The problem with that is, although the automatic system is very good at what it does, it's limited in the number of things it can do, which is a problem. It also happens to have been evolved for an environment that is completely different from the environment we operate in today, which is why you get all sorts of strange cognitive biases, which is why people make very poor financial planning decisions, because we didn't have to make that many financial planning decisions on the savannah in Africa 200,000 years ago, and the automatic system is not tuned for that sort of thing. So the effortful system is a good general purpose system, but it's one you want to use only when you don't have something automatic that works for you. Okay, so effortful and automatic. There's one thing I left out. Parking a car in a narrow space is very hard unless you do that for a living. If you're a car park and you manage to keep your job as a car park, you will get to the point where parking a car is as automatic as driving on the highway is for most of us. So a task which was effortful has become automatic. And I think that's kind of interesting because, remember, automatic is cheap and fast and good at what it does. So most of us do not aspire to park cars. Some of us probably like to play chess, One characteristic I have read of really good chess players that's not true of not really good chess players is when a really good chess player when really good chess players look at the board, they see only the good moves. When mediocre chess players look at the board, they see all the moves. And so you can think of the process that's going on here is the automatic system in the good chess player has been trained to filter out bad moves and only funnels the promising moves to the effortful system. And that clearly would give that person an advantage against someone who had to use the effortful system to evaluate every move. So this guy is Steve Freeman. He's a programmer in London, and he's a programmer, consultant. He bounces around a number of different jobs. He's been involved with a large number of the interesting things that have happened in software in the past 15 years. He worked on the first XP company in London. He was a co-author on the first paper about mock objects, and so on and so forth. So he's been around a long time, and he's a good programmer. And we were talking about this effortful automatic thing, and he told me something along these lines. Some of what he has to do as a consultant is he has to write bad code to give to people so that they can practice refactoring. And what he said is that as he's become a better and better programmer, it's gotten really, really hard for him to write bad code. Now, I didn't actually, at the time we had that conversation, I didn't think I was going to use him as a centerpiece for a talk, but so I could be misrepresenting some of what he meant, but the way I interpreted it as when he's looking at a problem, the good code is obvious there. It just leaps out in an effortless way, whereas it is an effort to write the bad code. He has to turn off the automatic writing of good code in order to write bad code. And so my goal became to be like him, because wouldn't it be great if the automatic system automatically wrote good code and it was an effort to write bad code instead of the other way around, which is the way it usually is. So I've become interested in, rather than working on the rational part of my brain, the effortful part of my brain, working on the automatic part of my brain. And that means that I want to train the automatic system. And I'm using as my model for this talk, at least, the way people like that person, that's my wife, train veterinary students at the University of Illinois, or in fact, the way they train them at Fort Collins up the road. So there's a diagnostic distinction that's important in veterinary medicine, and I believe in human medicine, but I'm not sure about that. So in veterinary medicine, one of the things you want to do when you're evaluating an animal, in addition to things like taking its temperature, taking its blood pressure, you also want to evaluate whether that animal is bright or dull. So that's a diagnostic distinction that's valuable when you're working with an animal. And the interesting thing about bright and dull is that to a veterinarian, it's a perception. It's the same thing as looking at a sheep and saying that sheep is green. They look at a sheep, for example, and it is as obvious to them that the sheep is bright or dull as it is to you and I that the sheep is green. But they don't start out that way. They have to be trained. Their perception has to be trained. And it's an interesting process, and I don't have time to talk about it in a lot of detail, but here are 3 parts that are important. First part is naming. That's fairly straightforward. They're not being asked to invent new diagnostic categories. They're being asked to take 2 words and train their brain to associate those words with a subset of the universe of animals they'll see. It takes a lot of repetition to get good at that. That's pretty straightforward. All kinds of learning takes repetition. Reaction, however, is the interesting thing. So they do not, a student of veterinary medicine does not learn to distinguish bright from dull by being shown a bright cow and being told, please list the characteristics that make this cow a bright cow. So they don't put a cow up on stage during tests and have them do that sort of thing, because that's engaging the effortful part of the brain. It's the systematic, step-by-step, decomposing part of the brain. And nor do they say, here is a dull cow, please modify this dull cow to become a bright cow. Like change the way it's holding its ears so they look more bright. They don't do that either, which it seems like that'd be a dumb thing to do, but consider that when we teach people to improve code, refactor code, we say, here's bad code, change it step by step to make it good code. That's not how they do their training. Essentially what they do, in short, is they present the student with an animal. The student has to make a judgment, bright or dull. The student is corrected in that judgment, and you simply repeat this process over and over and over again until the student gets to the point where they simply see the animal as being bright and dull. And in fact, asking someone, how do you know if an animal is bright and dull, strikes veterinarians as being kind of a stupid question. You can just see it. So we have some of the same things the veterinarians have. We have code smells, as documented in Fowler's book. And these code smells are much more akin to things like brightness and dullness than they are to things like high blood pressure or fast heartbeat. In particular, probably the most important code smell is duplication. And a very, very shallow view of duplication is all about, are there strings of text that are duplicates? That doesn't scratch the surface of what good programmers mean when they talk about duplication. So I've worked with good programmers better than me, and they can see duplication that is not apparent to me at all. And those programmers talk about even better programmers who see duplication that the good programmers don't see. And what they do is they describe, as if with awe. This is a particularly recollection of Ron Jeffries describing working with Kent Beck, where Kent would sort of say, well, here's some code over here. Let's move it over here, and let's change this a little bit. And all of a sudden, the duplication becomes obvious to Ron. And then they can go ahead and fix it. So we have the same sort of need to increase our perception when we're looking at code as a veterinarian does when they're looking at an animal. Though I think we have an advantage over veterinarians, which is a veterinarian only gets to see a sick cow for a period of a few days, and then the cow goes away. Maybe the cow comes back, but if it comes back, it's got a different disease, and it might as well be a different cow as far as perceiving whether it's bright or dull is concerned. But we are special in that we look at some code, and then we leave the code, and then time passes, and we look at the code again, and then we leave the code again, and then we look at the code again. So we revisit the same code over and over and over again. And I think that's helpful for us in learning how to improve our perception of what codes, whether there's duplication or other code smells, because I don't think I'm unique in that I often leave a piece of code with an awkward feeling that I know there is something wrong with this code here. I don't know quite what it is, but I have to move on. Or I come back to some code and I'm working with that code and I can't pinpoint the reason, but that code is just awkward to work with. I can't see why it's awkward to work with in such a way that I can change it, but there's just something wrong with it. And so I liken that to, there's just something just out of reach that I can't quite get. And sometimes I come back to the code and all of a sudden I get it. So my perception has increased one slight small amount. Okay, so what we've got here is, I think, the best way to learn to write good code is to revisit bad code or borderline code over and over and over again until you've trained your automatic system to be better at recognizing it. Now, it's hard to justify somebody paying a salary to say, I have to revisit this code and revisit this code and revisit this code for my professional development. But fortunately, we at GetSet, and me in general, we work using extreme programming. And actually, Ron Jeffries asked me to ask this question: how many people have even know what extreme programming is? Okay, so he'll be happy about that. He was one of the original extreme programmers, and he feels sad that Scrum won. So extreme programming is really, really fascinating. It's a collection of techniques, but the more I learn about it, the more I learn that there's a lot going on under the surface. And one of the things XP is about being a heavy, heavy learning tool. It's about learning as much as it is about performance. And one of the ways that it makes us learn is by this phrase, you aren't going to need it. And that's justified in most of the extreme programming literature in economic terms, which is to say, when you write code, if you anticipate how some other later future code will need to use the code you're writing, there's a fair chance you'll be wrong. And in that case, you will pay the expense of writing the code and pay the expense of not writing the code. So given that we're all kind of bumbling, clueless creatures, your best bet economically is to only write the code you need. But the good thing for learning is, if you do Yagni, that means you're going to be revisiting that code more and more and more and more often. And so I think that is the key to improving yourself as a programmer, is to go back and revisit your code with the attitude that you're trying to train yourself to recognize things that you didn't recognize before in the code. And that brings us to another topic about learning, which is you as a programmer situated in your world. Most of the time, programmers... So there was this one programmer I met who said, my body is just a thing that keeps my brain from falling to the ground. And he is an extreme case, because most of us think that we need something other than our brain. We need a big monitor and an ergonomic chair, and that's all we need for programming and learning. But that's not actually true, because we are embodied human beings, and we are social human beings, and you have to take advantage of that in the tasks you do and in the learning you kind of do. So I'm going to talk about that in terms of a phrase called set and setting. I first came upon this phrase in reading a paper about jazz musicians and intravenous drug users who both use set and setting to craft the experience. They're different experiences. Set and setting originally came about when discussing psychedelics. And I realized that I'm here in Boulder telling you about psychedelics, which is, I'm sure you have far more experience than I do with psychedelics, but nevertheless, you may not have heard this formalism about psychedelics. So, set and setting was coined by Timothy Leary, who was a notable Harvard professor who was very into LSD in the 60s. And the interesting thing about LSD was, not only did he study it in his living room in Cambridge in the 60s, LSD had also been studied by the CIA in the 50s. I think it was the 50s. And the CIA was looking at it as, we need a drug to use in interrogations. Is this a good drug? So they did a lot of that sort of work. And they classified LSD as an anxiety-inducing drug. And that was not Timothy Leary's experience of LSD at all. So, because he found it a mind-expanding, not anxiety-inducing drug. So his question was, what's the deal here? Why is the LSD experience so different for CIA subjects as for people in my living room in Cambridge? It's the same molecule in either case. And his conclusion was that the drug experience is it's not a function just of the molecule, it's a function of setting, and the molecule. So, set is about you. It's about, set is a word. You get set for something. You take a position. You adopt a stance. So, that's part of the set is your base personality. Part is the expectations you bring to the experience. Part is your mood. Part are certain ritual acts of preparation. And I'm underlining that because I'm going to talk about one of my ritual acts of preparation I use when I'm thinking about learning to be a better programmer. Setting is your environment. It's the physical environment you're in. It's the immediate social environment. We are herd animals. A big part of our brain is tuned to paying attention to people physically near us. So that part of the setting affects the experience. The entire culture. Part of the reason that the CIA got different results from Timothy Leary is that the culture Timothy Leary was working in was very different from the culture of the CIA, both in the organizational culture and the larger culture of the country. 50s versus 60s was a big cultural change. So those are the ideas of set and setting. And what I want to do now is there are these two people here who are going to do a demonstration. These are famous tango dancers. They're going to dance in a kind of a lousy setting, looks like a gym floor. Watch in the beginning. I think you can see, though the picture's kind of blurry, some of the things they do to establish their own set. So that's one thing to watch for. The other thing to watch for is I just think this is really pretty. Sound person, put the sound on. Okay, this actually stops there because I have this whole other thing I do about the close relationship between tango, test-driven design, and catching fly balls in baseball. And the particular move he just made is relevant to that. But if you want to hear that, sign me up for a lightning talk, and I'll tell you briefly about that. I dance tango. Does anybody here dance tango? There's one guy. So don't contradict me here. Tango is an unusual dance in that it is very, very highly improvised. And so, especially for the follower, who is typically a woman, it is a dance that requires careful non-attention to physical cues of the leader. And I mean non-attention because you have to train your automatic system to pay attention to those cues because the effortful system is too slow to be able to keep up with the leader. One of the hardest things for women, especially people like my wife who tend to over-intellectualize things in tango is just to stop thinking about it and let the man, the leader, move you. So tango, in my mind, is associated with sensitivity. And so when I want to prepare myself for a session where I want to actually really learn, I will actually make the same body movement as I do when I'm getting ready to start a tango dance, which is I lean slightly forward, I draw the body up, put the chest out. And to me, that is a ritual that induces the appropriate set for learning. You may have different rituals, probably, but rituals are important for this kind of thing. I also do setting, and this is an oddity of mine. I live in Champaign, Illinois, which is a university town, University of Illinois, and for some reason, noisy environments with lots of students bustling around puts me in the mood for learning more than sitting at home in my front window where I work or sitting in an office when I was in Chicago with the other people. So oddly, by paying attention to where I seem to respond best, I've noticed that noise helps me learn. And therefore, I do try to set things up that way. So I encourage you to do this sort of thing. And that's really all that I have to say, except you've been patient, and you've been nice to me. You haven't laughed as much as I'd hoped, but you've been nice to me. So one of the reasons I was hired at Get Set was to be a closure programmer. So I'm a Closure and Ruby programmer. I was actually introduced to Closure by Glenn Vanderberg, who will be the last speaker at this conference. I wrote a book called Functional Programming for the Object-Oriented Programmer. It's a fairly popular book. It's done really well. If I'd known it was going to do well, I would have gone through a traditional publisher, but it's published by LeanPub, which means it's an online ebook, and since you're nice, I'm going to give you on the next page a coupon that will let you buy this book, buy it for nothing. So, also I have 4 Diet Cokes here if anybody wants them. Because I can't drink them all. So that's the crazy idea I want to brainwash you into. Leanpub.com, FPOO, and the coupon code is Rocky. Please don't tweet that to your 50,000 followers. And that's all I've got to say. Thank you.